Hello class, I'm here to talk about chapter 11, problem 8. I did want to cover this because on week 4 you're going to be assigned a case that does work with this single serving waiting line model, but it's also going to work with the multiple server. So I'm going to go over the single server just to give you an idea how do you make comparisons to come up with an analysis. Right here it says for the Burger Dome single server waiting line in section 11.2. So you're going to have to refer back to your book. So let me get your book right here and see if we can do it together. So 11.2, let's go over here, chapter 11, 11.2. Okay, we can get rid of that. Okay, so right here it's talking about a business, operating characteristics, and giving you the formulas. And finally talks about operating characteristics for the Burger Dome problem. So if you wonder where I got these values right here for one server, it's coming from right here, the book. Okay, it's talking about a arrival rate of 0.75 and a service rate of one customer per minute. So if you go ahead and put it here, I did leave the formulas for you, the ones that I presented before. So all you need to do is to put 0.75 and 1. And then you're going to see that these values are going to match exactly what I have typed in the table before. So that's how we have this in here. But I'm deleting this because the problem is gonna ask you assume that the arrival rate is increased to 1 instead of 0.75, and that the service rate is increased. It's supposed to say increase, right? Increased to 1.25. So right here it's gonna go 1 and 1.25 and compute the following operation characteristics for the new systems: P0, LQ, WQ, WP, POW. Does it provide better poor service compared to the original? And to discuss the difference and the reason for this difference. So right now, if I remove this, you're gonna see it's gonna give me an error because it's dividing everyone here by 0. Okay, so I still have these values. These values are just typing here because those are I'm just bringing from your book, from these values right here. If you want to see exactly how it worked, the formulas, it's right here. So let's close the book and just put it on the side in case I need it again. So now it says we increase the arrival rate to 1 and the service rate to 1.25. Oh, 1.25. So you're gonna notice that automatically it's gonna populate all this for you because I already did the formulas. If you refer to the previous problems, you're gonna see all I did. It was just to follow the formulas for these values. Okay. So and I also create a little table because it makes it easier to see the values. How did they change? Okay, just by looking at this information right here, at first you're gonna say, "Oh, great! Look at that! Now the customers that probability that no customers are in the system went down." Okay. Um, well, that not necessarily is good. It's actually bad because before you have a higher probability nobody was in the system. Okay. So now we have the average number of customers waiting in line. Well, that went up. We have an average time of customers wait for service. Well, that went up. We have an average time a customer spends in the system. Well, that's the same, but our probability of an arriving customer has to wait went up. So even though the service rate increased to 1.25, that means we are servicing more customers per minute. Yeah, that's great. But definitely it provides a poor service because now um, arrivals are occurring at a higher rate. Does that make any sense? We're serving more customer, therefore, the arrival rate is also going up. The average wait time might be the same, but there's a probability that there's a probability of waiting, and the number of waiting increase with the new system. So how would you put in this in words? So let me just do a little table right here so we can see that even though the service rate, which is mu, right, is increased to 1.25, the system provides a worse service due to the fact that arrivals are occurring. Something's wrong. Occurring to see, yeah, it's right, at a higher rate. The average waiting times are basically identical with exception of WQ, but if we're gonna round down anyway, so they are basically identical, but there is a higher probability of waiting, and the number waiting increase. I guess I can type today with the new system. Okay, here's the thing. You do rep text, and then it fits all in the box. And then you can go up and down here, or just to see how you want it, in the middle, not middle. Okay, so that's what this means. It keeps everything in the box. You first merge, and then as big as you want, and then you do the wrap, if I didn't address that before. So think about it. If you're going, like I said, Disney World, Disneyland, you don't want to wait longer than you should, that you were going to wait before. I was at Disney World last year, and on Halloween night, actually at Universal on Halloween night. So you figure one of the lines for the main attractions was over 2 hours. Anything that you put any minute, that 2 hours is already absurd. Any minute, any second that you put on that wait, it's gonna make people very, very mad. So unless you buy the whole express and everything, and even then, even on express, when you have a 2 hours wait, your express is gonna probably be at 30 minutes. You don't want to wait 35. You don't want to wait 32. You don't even want to wait 30. So anything that increase, it's bad. So that means even if you increase, bringing more customer servicing more customers, not necessarily you're being able to service them correctly and properly. So when you do your case for week 4, that is going to be due at the end of week 6, try to think like that. Okay, some of those numbers might lower, but not necessarily means it's a good thing in the end. Did it, the probability of an arriving customer or a car has to wait for service, did it increase? How much did it increase? But also you have to, when you're working with multiple servers, the cost of one server and the cost of more than one server, is it worth paying more than one? Like, is the difference so dramatically that you should put more than and do a multiple server? So just think of all that when you're analyzing your case for week 4 that is going to be due in week 6. I hope this helps to clarify a little bit, and let me know if there are any questions as